Hello, I'm Tassity Ebacher. I'm a student at the University of Minnesota Crookston. Today I'm going to do a tutorial on binary numbers. We'll talk about binary numbers, how to convert binary numbers to decimal numbers, how to convert decimal numbers to binary numbers, how to add binary numbers, and how to subtract binary numbers. So before we get into binary numbers, we should talk about decimal numbers. Decimal numbers is the numbering system that most people are used to. It's a base 10 numbering system, meaning that there are 10 total digits used, 0 through 9. Every decimal number uses only these 10 digits, no matter how large the number is. So what is the binary numbering system? It's a numbering system used by computers, mainly. Binary is used by the underlying code that computer hardware uses, not what you see in the operating system. It's a base 2 numbering system, meaning that there are 2 total digits used, 0 and 1. Every binary number uses only these 2 digits. 0 represents off, while 1 represents on. Computer hardware has switches in a circuit that can only have 2 states, off or on, meaning there either is not or is electrical current running through the switch. This corresponds to the binary off and on digits of 0 and 1 that make up binary numbers. Modern computers do not have switches that can have more than 2 states, therefore binary is necessary for computers. 0 representing off and 1 representing on is important to remember for the next section where we discuss how to convert binary numbers to decimal numbers. How to convert binary numbers to decimal numbers. The easiest way to learn how to read binary numbers and to convert them to decimal is to use the following technique. You start off with a chart of what each digit place represents in terms of decimal number value. I've provided a worksheet that has this chart on it for you to use, and it is linked below. However, if you don't want to download the worksheet, it is very easy to create this chart yourself. We're going to start with an 8-bit binary number, meaning it has 8 total digits. Started out by making a rectangle that has 8 separate sections in it. And then another one below that that also has 8 separate sections. So you start at the far right and you put a 1 in that place. And then you double that number, move to the left, and put that number in here. So that would be a 2. And then you just repeat that process. So double 2 is 4. So you put that here. And then double that and move to the left. And that's 8. And here's 16. 32, 64, and finally 128. So that's the basic chart that you want to start out with when you're going to convert a binary number to decimal. First example, we'll start with a very simple binary number. The binary number that we'll use is just all ones. So it's going to be 1111, 1111. And what you do is you put each of these digits into the chart that we just created. Being it's all ones, just go through and fill it out. And how you determine what the decimal number is for every digit that is on, and if you remember, an on digit is a 1, so you take 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. You add all of those, what it equals is 255. And that is your decimal number. So you know the binary number 1111 equals 255. And just a little note, the binary number of 1111 is the largest binary number that you can have, that is 8 bits. Next, let's learn how to use the 0 digit in binary, which represents off. For this example, we use the binary number 0, 1, 0, 1, 1, 0, 1, 0. So that is 8 digits long. And so what we're going to do is put that into our chart. 0, 1, 0, 1, 1, 0, 1, 0. So as we remember, every time that we see a 0, that represents off. So we would not add that number up to convert this to a decimal number. So 128 we would not add. Instead, what we would add is 64, but not 32. We would add 16, 8, and 2. And when we add all of those up, what we get is 90. The binary number of 0101, 1010 equals the decimal number of 90. Now that we're comfortable with this concept, we'll move on to convert a decimal number to a binary number. To convert decimal numbers to binary numbers, we'll use the same chart that we wrote earlier. We're still going to stick with an 8-bit binary number, so we will only convert decimal numbers lower than 255, since that is the largest 8-bit binary number that is possible. The first number that we'll convert is 199. So what we want to do is just kind of write that off to the side of our chart. The first step is to take 199 and ask yourself if you can subtract the first number on the left in our chart from 199 without going negative. So can we take 199 minus 128 without going negative? Of course the answer is yes, so we go ahead and put a 1 in that column, and then we subtract 128 from 199, and what we have left is 71. Next, we ask ourselves if we can subtract the next number from the number that we have remaining. So can we subtract 64 from 71 without going negative? And of course the answer is yes, we can. So we put a 1 in that column, and what we have left is 7. So I'm just going to move that up here. That's what we have left. So we just kind of follow this process throughout. So then the next thing we ask is, can we subtract 32 from 7 without going negative? And of course the answer is no, so we put a 0 here. We can't subtract 32. The next one is 16. Of course you can't subtract that. Can't subtract 8. We get to 4, which of course we can subtract without going negative. And now we have 3 left. And we put a 1 in that column. And of course we have a 2, which we of course can, so we subtract 2, and then we have 1 left, and so we put a 1 here, and if we subtract 1, of course we get 0, which is exactly what we want to have. So now we have our binary number of 110001111, which is the same as 99 in decimal. Something important to remember is that if you get to the end of your chart and you're at the 1 and you have more than one digit left over here in your math, then there is something wrong with the math that you did. The whole point of binary is that you should never have anything left over at the end and should always come out to a 0. How to add binary numbers. In order to add binary numbers, one thing that you could do as an alternative option, of course, is take the binary numbers, convert them to decimal numbers, and then add them, and then convert that number to a binary number again. However, it's a lot easier to actually just add the binary numbers. So we'll start with an easy example. For this, we're going to go with just a 4-bit binary number to start with. So let's start with an example of 0, 1, 0, 0, and we're going to add 0, 0, 1, 0. So for this one, it's really simple. Basically, you can just go through and add the digits up as you normally would with a decimal number. So of course, this is a 0, so it would be 1, 1, 0. So that would be our final outcome. For this example, we'll start with the more difficult number of 0, 1, 1, 1 plus 0, 1, 1, 0. So of course in this first column on the right, we would get a 1, because 1 plus 0 equals 1. And over to the left, we have 1 plus 1. So when you have two 1s, what you do is you put a 0 below there, and you carry a 1 to the next place. The next column to the left, we have 3 1s. So what you would do is put a 1 below that, and you also carry a 1. So then in the farthest column to the left, of course, we have a 1 and 2 zeros, which of course is a 1. So to make sure and verify that we do have this correct, if we just do the math on this quick, of course this is a 7. 0, 1, 1, 1 equals 7. And 0, 1, 1, 0 is 6. And 1, 1, 0, 1 is 13. Now, of course, if we take 7 plus 6, we get 13, so we know that these are correct. So that's the basics when it comes to adding binary numbers. Of course, it just follows the same principles as you go along. Now this next example is a little bit more difficult. The numbers that we're going to add: 0, 1, 0, 0, 1, 1, 1, 0, plus 0, 0, 1, 1, 0, 1, 1, 0. Now, the thing that you need to remember is when you are adding these binary digits, 1 plus 1 equals a 0, and then you carry a 1 to the next line. And then if you have 1 plus 1 plus 1 equals a 1, and you carry a 1. So hopefully that makes sense, and as we go through the example, I think it'll make more sense. So we start at the right. 0 plus 0, of course, equals 0. Then we go 1 plus 1, and like I said before, that equals 0, and you carry a 1. So we put it over there on the next column. And then here in this third column, we have 3 1s. So 1 plus 1 plus 1 equals a 1, and you carry a 1. Let's put that over there. So here again, we have 2 1s, so we equal 0, and carry a 1. 2 1s equals 0, carry a 1. 2 1s equals 0, carry a 1. 2 1s equals 0, carry a 1. So then in the first column here, we have only 1 1. So 1 plus 0 plus 0, which equals 1. And then if we, I'm going to delete this here, but if we next convert these back to their decimal form so we can verify our math, this first number 0, 1, 0, 0, 1, 1, 1, 0 equals 78 in decimal. And the second number 0, 0, 1, 1, 0, 1, 1, 0 equals 54 in decimal. So if we take 78 plus 54, we get 132. So next thing we need to find out, is this number in decimal form, does it equal 132? So if we go back to our beginning of this lesson where we converted numbers, we know that the first number is equals 128, and then this number here equals 4. So 128 plus 4 does equal 132. So these are equal, so our math is correct. How to subtract binary numbers. Subtracting binary numbers is very similar to typical decimal number subtraction. So let's just first start with a fairly easy example. 0, 1, 1, 1 minus 0, 1, 1, 0. So of course 0 minus 0, that's just 0. 1 minus 1 is also 0. 1 minus 1, also 0. 1 minus 0, of course we have 1. So here we have 0, 0, 0, 1. Next, let's start with a slightly more difficult example. 0, 1, 0, 0, minus 0, 0, 1, 0. So in this scenario, we are going to have to borrow from the left for the numbers in this column. Because 0 minus 1, you can't do that because you'd have a negative number. So we need to borrow from the column over in the left, from this 1. So basically what we do, cross out this 1, and it becomes 2 1s. So I'm just going to put them up there. I know it looks like an 11, but it's actually 2 1s, which is slightly confusing. But then you just take 1 minus 1, and you still have one of these 1s left. So we're going to put that here. And of course, 0 minus 0 is 0. So in this point, we would have 0, 0, 1, 0. And let's just do the verification on this. So the number 0, 1, 0, 0 in binary equals 4 in decimal. The number 0, 0, 1, 0 in binary equals 2 in decimal. And of course we have 4 minus 2, which should equal 2. And if we look here, 0, 0, 1, 0, we know already that that is 2. So that verifies our math. So for this one, let's go with 1, 0, 0, 1, 0, 0, 0, 1. So we're going with an 8-bit binary number, and we're going to subtract 0, 1, 1, 0, 0, 0, 0, 0. All right. So again, we start at the left, right here. Don't want to do that yet because we need to borrow here and here. So we're going to take this first one, cross it out, and that equals 2 1s here. That's going to equal 2 1s in this column here. And we know we need to borrow in this column as well. So we're going to take one of these 1s, cross it out, and put it over here. And that becomes 2 1s again. So let's go back to this second column on the right. 1 minus 1 equals 0. And actually we can fill in this 0 too for the first column. And then let's move to this column. 1 minus 1, and we actually have 2 1s, so that would be a 1. So basically these 1s, those ones cancel each other out, and then we have one remaining 1, so we put that here. Now the rest of the math is pretty easy. We have a 1, 0, 0, 0, 1. So our number 1, 0, 0, 1, 0, 0, 0, 1 equals 145 in decimal. And then our next number, 0, 1, 1, 0, 0, 0, 0, 0 equals 96 in decimal. And then let's just figure out our third number right away. So 0, 0, 1, 1, 0, 0, 0, 1 equals 49. And of course, if we do the math and take 145 minus 96, we get 49. So we know that our math is correct. And once you're comfortable with this, of course, you probably don't have to do the math every time, but when you're first starting out, it does help to verify that you've done everything correct. In the beginning of this tutorial, I had mentioned a worksheet that is available for you to download, and I just wanted to show what this worksheet is and kind of describe it. So basically, it has the examples that we went through in gray. They're all shaded in gray, so you know which ones are the examples we went through. And those ones, of course, I do have the answers filled in. So this worksheet can be used to kind of follow along as you go through this tutorial. And then anything that has a blank space, of course, is where you can do your own work. And I did include a couple tips here, such as this part at the bottom, where it's talking about adding binary numbers. and how that works with what number you would get and how you would carry that number. And then of course on the second page I do have the answers, and they're all in red. So just to kind of show that very quickly, I would recommend to download this worksheet and kind of work through the problems. If you have any trouble going through it, I would recommend to go back through that section of the video and review it, and then see if you kind of missed anything that you can kind of work through the problem after that. This tutorial was beneficial, and at this point you have a better understanding of binary numbers and also know how to convert them and add them and subtract them.